Hi, my name is Olumuyiwa Durujai. I'm a senior software design engineer on the Windows team working on the input stack. So today I'm going to be talking about touch firmware development for Windows. As you may know, we've had touch input since Windows Vista, but now we're moving forward. The world is a very different place today, and what we're trying to do is make some improvements to what we have or what we had in previous operating systems. So in Windows 8, we have a new set of features around touch. We have new requirements, and we believe that we're going to have a better user experience from end to end. So the agenda that I have today is listed on the slide right now. I'm going to be talking about touch digitized data delivery, and what I mean by that is getting data from the device firmware to the host. And while talking about that, we're going to look at the driver stack for touch devices and how inputs delivered all the way to the client at the consuming client. Now, one central key thing that we use for data delivery is a human interface devices specification, which is a USB standard around human interface devices, things like touch input, mouse input, and keyboard. And we're going to be taking advantage of that quite a bit in touch. We've been doing that in the past, but we're going to center on it more in Windows 8. Now we're going to talk about two buses that we're concentrating on for Windows 8. That's USB and I2C. And I expect that once this talk is over, the listeners will be able to take away a good understanding of how touch hardware data is delivered to Windows, and know about the resources where they can get more information about what Windows 8 is all about as it relates to touch hardware. So let's start with the good news. The good news is no driver development required. Well, we're not asking IHVs to develop drivers anymore. Actually, a little bit of this has been going on from Windows 7 and even back as far back as Vista, but we still had a lot of drivers even when in Windows 7. So what we're trying to do now is make sure that IHVs can focus on the firmware development and reduce production and maintenance costs. And that way we believe that we can get a better experience for everyone, and saving time on both sides. That's on the host side and as well as the firmware in terms of development costs and maintenance. Now, how are we going to get this done is a key question here. And what we're going to do is we're going to take advantage of the human interface device specification. And what that simply means is we're going to use the power of HID. HID is a very flexible standard, and it makes it possible for us to extract data from firmware and interpret it, even though we don't have full knowledge of what the firmware data looks like. So, like I said earlier, HID is actually a USB standard, but what we're doing in Windows 8 is we've extended HID, so we have a protocol that allows it to work over the I2C bus as well. So firmware developers for Windows 8 will have an option to use either USB devices or I2C devices. So what we're looking at right now is the touch input architecture for Windows 8. So I'll just walk through the diagram from the bottom. If you look at the bottom, we actually have two separate stacks here. If you look closely, if you look at the red part where it's clearer, there's a USB stack that's on the left, right here, and then we also have the I2C stack on this side. So essentially what's going to happen is IHVs will only need to worry about writing the firmware, as I said earlier. So the only portion of this architecture where the IHVs will have their code will be in firmware, and everything else will be handled by Microsoft. So the red portion of both stacks actually represents the bus-specific drivers on the side of a host. And if you're familiar with the USB stack on Windows, you'd know that there's actually a complex architecture hidden under that red portion of the diagram. The I2C story is a little simpler, but it's not really that relevant to the current discussion, so I just left those out. Now, at the top of that, the blue section where we have the heat class driver, if you've done any heat data delivery in earlier versions of Windows, you know that heat USB has been part of our operating system for a long time. We've had previous releases where we've had heat USB. So now heat USB.sys and heat class.sys actually make up a WDM unit. So heat class is the class driver and heat USB is a mini driver. And both, like I said, both of them make up a WDM unit. So they actually act as one driver. Heat class does most of the heavy lifting, while heat USB talks to the device in a bus-specific way. Now on the other side, we have the heat I2C.sys device, which also acts as a unit in addition to the heat class driver. And what actually goes on here is heat I2C extracts data from an I2C device the same way the heat USB.sys would do on the USB side. And once data is extracted from the device in this way, it's delivered to Win32K, which is responsible for every kind of input today, which wasn't the case in previous versions of Windows, but in Windows 8, we're going to have input go through Win32K, although input as in keyboard, touch, and pen data, everything will flow through Win32K, and that way things are better synchronized. So let's talk a little bit about the details of communicating with the host. How do we get communication to flow through? And here I'm going to talk a little bit about some of the new things in Windows 8, and then we'll talk about some of the rules, the heat rules that the firmware needs to adhere to make sure that everything flows through the Windows 8 stack properly. So what's new in Windows 8? So in previous versions of Windows, a lot of the devices were actually UART devices. And even though we use heat, like I said earlier, device drivers were responsible for translating the UART data to heat data. And then it was responsible for delivering that heat data to the host via the heat class driver. So since we're only going to concentrate on USB and I2C mini drivers for Windows 8, we're not going to allow any more serial UART drivers or devices in Windows 8. In addition to that, we're going to have stricter rules in terms of how data is structured and delivered. So that way, since we don't have a driver that can compensate for hardware-specific anomalies, we want to make sure that the firmware adheres to the strict rules so that the inbox drivers can deliver the data accurately. And then in addition to that, we're going to have a brand new certification process for Windows 8 devices. And that's, again, to make sure that we maintain quality for these devices and ensure that the user has a great experience. Again, the two buses that we're going to support for Windows 8 Touch is going to be USB and I2C. Now, a little bit of details on the heat rules. Obviously, if you're going to write a heat device, you have to be familiar with the heat specification. I have a link here to the heat specification. And then the heat usage table document is actually a great document for details about what heat properties and heat devices, the different classifications of devices, and what properties you have within each classification. It's a detailed document that anyone who wants to write a HID device needs to be familiar with. And then in addition to those two documents, you know there's a USB document. Like I said, HID is a USB standard. In addition to those documents, we're going to have a protocol document, which is Microsoft specific. And what that protocol document just does is it ensures that data that's delivered is in the way that we expect it to be. And the reason why we have this document is to make sure that anyone who wants to write HID firmware can do it in a way that would be fully compatible in Windows 8. And we've had feedback in the past that our documentation wasn't sufficient to deliver good data. And here's our opportunity to do something about that. So now we have a detailed document. All the details that we require are within this one document. That's information that's outside of the regular HID standard. Everything that we actually request is within the standard. We just have more specifics since the standard doesn't go into the kind of details that we'd like. So, device and report descriptors. These are regular items that you'd find in HID devices. The report descriptor actually gives details about the input reports, the output reports, and the feature reports that the device supports. Output reports aren't really relevant for touch input since data flows in from firmware to the host. So we will have feature reports though, so we can configure and query for configuration of devices. So the device descriptor actually has information about what the device is and a bunch of other properties that you can find out about the device. The device descriptor is for I2C devices is slightly different from the device descriptor for a regular HID USB device. But ultimately, that's just a reflection of the different bus architectures that we have for both. So regardless of the bus that the device is actually connected to, what we essentially have the same set of HID requirements on both ends. The delivery mechanism is just slightly different. So we have required usages for all touch devices. The required usages must be supported by every touch device that's going to work with Windows. And these usages include X and Y for the position of the finger, the contact ID, and the contact ID. The contact ID is the identifier we use to know to identify one contact. So if a finger goes down, right from the time the finger goes down till it goes up, the contact ID needs to remain the same. So if you have multiple fingers on the screen, we can identify it using this contact ID. The contact count maximum lets us know right at the time we discover the device how many contacts, as in how many fingers the device can support. Some devices can support 5, 10, and maybe a few hundred. But the contact ID maximum lets us know what the maximum is, so we can make adequate preparation for as many contacts as the device can send us. So we also have the tip usage, which essentially lets us know the state of the current contact. Optional usages that we have include pressure, width, height, azimuth, and azimuth is just the orientation angle for the current contact or finger. So we also have the in-range usage, and that's for devices that are able to detect contacts that are hovering over the surface of the digitizer. Even though that's not common, some devices are able to do that, so we do support that usage, and devices that support it can take advantage of that. So in reporting data, we have two different reporting modes. We have the parallel mode and the hybrid mode. The parallel mode allows a device to deliver all the data, all the contacts it has in one frame, within one report. A hybrid reporting mode is a little different. It allows you to report data for one frame in multiple reports. And the reason why you'd want to use parallel over hybrid is, say you have a device that you know that the most common usage is delivery of 10 contacts all the time. You know that then it's advantageous to deliver the whole frame within one report. Now for the hybrid mode, if you know that you have a device where maybe most of the time there's only going to be one contact on the screen, then it makes sense for you to deliver just one contact at a time so you don't waste bandwidth. And then, when there are more contacts, you can take advantage of a hybrid mode to deliver the data and still be able to deliver frames. Now in Win 7, we had a third reporting mode, which was called a serial mode, but that didn't have a way to deliver frames. And we've had feedback from application developers that they'd rather deal with frames. So we're not encouraging the serial mode in Windows 8. So here we have a copy of a report descriptor. This is what a fairly common report descriptor will look like on Windows 8 touch devices. So I'm just going to walk through some of the usages we have here and highlight the required usages, as I mentioned in the last slide, and the optional usages and what some of this stuff means. So for the people who've been doing HID devices for a while, I mean, you know that there are three different kinds of items in a report descriptor. There's a main item, there's a global item, and then there's a local item. So a main item actually identifies data that goes into an input report or a report in general. It could be an input feature or output report. Now, a global item can be thought of as an attribute for the main item. So I'll give an example as I walk along the report descriptor. The global items, once they're specified in a report descriptor, they stay the same till they're changed. And I'll give examples of that as I walk through the report descriptor. So and the local items, they're also attributes of the main items, but the difference between the global item and the local item is the fact that a local item doesn't go along with each main item. A global item will stay the same till you change it. A local item just sticks with the current main item, and it needs to be re-specified when you want to write in a new main item. So let's go through the main items in this report descriptor. So I'll just carefully identify the main items that we're looking at in the current slide. So this is the first main item, and it's for the tip button. And we have another main item here, and that's for it's actually padding. So you can get the first main item was actually a 1-bit main item. So there's a padding for byte alignment here, which actually isn't necessary, but it makes it a little easier for you to deal with your C structures. So the next main item is the contact identifier that I talked about. And the next main item here is for X. And the last main item on this page, this report descriptor actually goes on to the next page, is for Y. So here we have 5 main items. The first one's for the tip, which gives information about the current state of a contact. Next main item is a contact identifier. We have a main item for X, and then we have one for Y. And you notice that all of this actually are in a logical collection. And a parallel mode device can have multiple logical collections for each contact. A hybrid mode can have that as well, but the difference between both is a parallel mode will have all the logical collections for all the contacts it supports, while a hybrid mode can split logical collections across, or can split reports, can split the contents it has across logical collections. So moving on, we're still looking at the same report descriptor. Here we have some optional usages. So the ones we're looking at right now is width and height. So here you'd notice that the width and height usage are sharing a main item, and the reason why that's possible is because of the flexibility of the heat standard. And if you take a look at some of the resources I'll show later, you can get more details of how you can compact your report descriptor so you save space as you construct the descriptor. So the next main item we have is the azimuth main item. So within each main item, as I said, we'll have global items which are listed here, which gives you the attributes for the main item. Now at the bottom of this, we have the scan time main item. So what the scan time main item delivers to the OS is the deltas of scan time as the digitizer detects contact. So when a contact is detected, the delta is sent to the host. Now, details of this are all in the protocol document that I mentioned earlier in the talk. So the next main item we're looking at here is a contact count main item, and that's for hybrid devices. So when a hybrid device has split its frame data across reports, it's able to let the host know how many contacts are actually in the frame by sending that data through the contact count main item. So this is the last part of the report. There are a few more features. There's a feature main item right here. And that's actually delivering the device identifier and the contact count maximum that I mentioned earlier. And then there are some custom feature main items down here as well. So that pretty much covers what a fairly common report descriptor will look like for Windows 8. What's going to happen is once the host detects the report descriptor, it's going to know how to interpret the input that comes from the device. So the report descriptor is kind of like a map to what input to what data is contained in every input report that the device sends to the host. So in a nutshell, that's what we are expecting from devices for Windows 8. There are a number of build talks related to touch hardware and APIs for applications that want to consume touch data. So there's a touch hardware and Windows user experience that talks a lot about the details and all the reasons why we're putting in so many rules for Windows 8. The tuning and testing talk is going to detail all the information about how we're going to certify hardware for Windows 8 and why we're running the test and what kind of tests we're running and what kind of tests we're actually going to hand to IHV so they can go test their devices to see if their device will be certified for Windows 8. So the next talk is make great touch apps using HTML5. As you may have heard, a lot of the apps for Windows 8 can be written in HTML5 and touch isn't left out. These applications will be able to use touch as a way of retrieving data. Touch and gesture platforms in WinRT and Win32K. We'll talk about APIs for the more regular Win32 developers, as well as the new WinRT platform as well. So it will be great if you can take a look at some of these talks to get more information about the whole story for Windows 8 around touch. So further reading, you can get more information about what I've shared here. I have links to USB specification and the HEAD specification rather, and the HEAD usage table. And then there are a bunch of links on MSDN that you can take advantage of. The protocol document is the main one that you want to look at for touch firmware development. and it has a lot of detail in it right now. And like I said before, all the information that required is in that one document. You don't have to go to multiple places to find information you need to write touch firmware for Windows 8. And there are a couple of other links here as well that will be useful to touch firmware developers. So with that, that's the end of my talk. I hope you've gotten some valuable information from the information I delivered today, and enjoy build. Thank you.